Today we will be learning about index notations. So let's start. Uh, the here in the subscript and superscript of A is called index. And let's first talk about the summation in index notation. In earlier you have seen this symbol of summation where we vary I from 1 to n and do the summation. But in the index notation we don't need to write the symbol, just write AIXI and it will denote summation. Here the index which is appearing twice, uh, it is the summing over index. So here we can see AIJ J is repeating twice, hence will sum over J. AI1 B1 plus AI2 B2 plus AI3 B3 like this. J is uh, a dummy index because it is repeated more than once, here twice. It We call it a dummy index. It We can change the replace the dummy index variable with any other variable which variable which we are changing it with must not be present earlier in the form. You have to keep this in mind. Now, and also the range must be also the same. Here we are taking the range of j from 1 to 3. Then if we replace j with k, then its range should also be from 1 to 3. And here I, which is appearing once, is called the free index, which can be replaced. And keep this point in mind. No index can occur three or more times in a term. Here in this example, AIK plus AKI there are two terms. In both the terms, K are appearing twice. Hence, K is a dummy index in both the terms. Now, equation involving indices. We must see whether the equation is consistent or not by examining the number of free indices and dummy indices on LHS and RHS. The free indices on both sides must be the same. Here, AI I is appearing once, hence in LHS I is a free index, and in RHS also, in both the term I is appearing once, hence it will be a free index. Now let's talk about brackets in indices. Uh, Look at this, Aij times Bi plus Cj plus Dk. We cannot directly do addition here because we have not proved the theorem yet, proved the identity. Uh, we are taking combination of each term. Aij combined with Bi, Aij combined with Cj, and with Dk. In each of the term, we compute how many free indices, how many times each indices is appearing. I is appearing twice here, and J is appearing once. Similarly, in other two terms also. And at the final, we count the highest number of appearance of each index. From these three, we can conclude that I is appearing highest twice, J is twice, and K once only in this. So we can say the term Aij times Bi plus Cj plus Dk. I and J are dummy indices and K is a free indices. Now let's look at some identities. The first identity is like this: Aij times xi plus yi is equal to Aij xj plus Aij yi. This equation can be proved consistent by just computing number of free indices both sides and then do the LHS and LHS is equal to RHS and that's done. Uh, So the second identity is like this: Aij xi yj is equal to Aij yj xi. Here, just the uh, x and y term are interchanged. Third identity: Aij xi xj is equal to Aji xi xj. Here, the ij here and j here, the I and j are interchanged. The fourth identity, Aij plus Aji times Xi Xj is equal to 2 Aij Xi Xj. The proof is very easy. We can just uh, uh, do the summation in the LHS. And while doing the summation, it will the first expression will become like this, and then expand, and then expand it for j is equal to 1, 2, and 3, and you will get many terms cancelled, and the final expression will be like this. There is a fifth identity as well. Aij minus Aji times Xi Xj is equal to 0. This can be also easily proved by expanding the LHS. And we may have encountered a Kronecker delta before. The definition of Kronecker delta is like this: del Ai is equal to 0 if j is equal to, sorry, this is not I, this is j. So del kj is equal to 0 if j is equal to k, and 1 if j is equal to 0 if j is not is equal to k, and 1 if j is equal to k. At last, let's look at some other examples. Here, dou vi dou xi. Uh, the I is repeating here, since we will sum over I. Dou v1 dou x1 plus dou v2 dou x2 plus dou v3 dou x3. And similarly for dou square phi dou xi here, dou 2 phi dou x1 2 plus dou 2 phi dou x2 2 plus dou 2 phi dou x3 3. So basically the I is repeating here, hence we are summing over I, what we have discussed in the uh, starting of this video. So here we will conclude today. Thank you.